Good afternoon, everyone. Thanks for coming to this session. I know you have other choices to go to, but you chose DLM. Hope you'll get definitely some information out of this session to understand what DLM is and what Hortonworks is really doing around the disaster recovery and replication scenarios. So today we look into the implacable data, the advancement of this unstoppable data that's coming from so many devices from the entire world, and see how we can address and how can we manage, secure, and govern the data that's coming from several devices. So that's where we will be talking to. My name is Neeru Anisetti, product manager from Hortonworks. Sweta from engineering management, and she is my counterpart in the engineering division helping out with data lifecycle manager. So the trend that we are seeing today in the big data trend, the number one, this has come in 2016 from Frost and Sullivan. What they said was 90% of the data that we see today has come in the last 2 years. Every 18 months, the digital content is being replicated or doubling. That data could be from unstructured or structured data from various sources. We have 7+ billion people having about 20+ billion devices. And then you can imagine the number of bytes that they're producing every single minute of the day. And this is the data proliferation that we are looking and then seeing how can we manage this data around. And you can see from that study, by 2025, we will have 100 zettabytes. Just the 1,000 petabytes that you can see every single year. So why is that big data trend important for us? It's important because there is a big market opportunity for Hortonworks. We want to seize that opportunity. The value of that opportunity is $1.9 trillion. Yes, we can get a fraction of it, but that's what we are after. And especially on the big data and the cloud, that's after looking at data science, streaming, and then IoT data or revenues that we are looking at. And how is Hortonworks planning to address this one? We're planning to address through DataPlane service. So Hortonworks plan to bridge the gap between the HDP, the data at rest, and then HDF, data in motion. So this is the DataPlane service platform that we are building to bridge the gap between, and so that this can be an extensible data management services to address the compliance and regulatory requirements, to provide consistent security and governance across the data landscape, and to also enable management and movement of data sets from one region to the other one, and to share and collaboration. So this is what really addresses the gap that we have today at Hortonworks and in general. So where does really DLM fit in this scenario, in the DPS? So DPS, if you click one more here, so DPS is the one that we have where it becomes one of the extensible modules that sit in that extensible services layer, where we have the DPS platform underneath and the extensible services that sit really using all of the services underneath. So that's the module that we would be talking for the next maybe 20-25 minutes. So the DLM service itself is a one that adds on to the DPS service to safeguard, to manage, to govern, and move the data. And it also has other features in addition to the DR, and DR comprises of replication, failover, and failback. In addition to the DR, we're also looking at the auto-tiering. So you have data in different tiers, and now you want to reduce your total cost of ownership, whether you move the data from SSDs to hard disks to archival storages. So we want to help those customers who want to really reduce the cost of ownership of the storage. And we're also looking at backup and restore. How can we really help navigate the failures that happen because of the human errors? So you can restore back to the clean data set from the previous day or a previous hour. And the last one that we are looking is offline replication. If customers have petabytes of data, just transferring that petabytes of data from one place to the other one takes several days, if not weeks. So how can we really sit down and help those customers to reduce that time to copy the data and then use offline replication. So all of this is to really alleviate the pain point of making sure you have the right security policies, you have the metadata before you move the data to the other side. So that's exactly what DLM addresses today. Those are the use cases that it goes after, where it maintains the common metadata and security policies across the regions and across all of the hybrid environments, whether it's on-prem or on cloud. So we released DLM last year in October. The first version came out with HTTP 265. It has support for HDFS and Hive. So the first feature is it's not only the data, bootstrapping of the data from one region to the other region, but we have an incremental replication for Hive and HDFS. And we support the snapshot-based replication for HDFS, and we also replicate the ranger policies that you set on top of the data sets. We support data at rest and data in motion using TDE and TLS. And that happens either you have the same key on both the ends or you have different keys. And we support Ranger KMS at this point. So we released something about 3 weeks ago. In that release, now we support replication of data directly to S3 buckets, HDFS data to S3 buckets without the HTTP on cloud. For Hive, you do need HTTP as an IaaS. And because we use Ranger on the target cluster, you can use a deny policy on the cloud or on the target cluster, and you can make that side as a standby side. So you can have an active where you can have reads and writes on one end, and you can have read-only version on the target. So you have an active standby behavior of your DR cluster. So those are some of the features that we built, and we have a lot more features that are in the roadmap to be built for DLM. So quickly going over a very quick demo. So this is the UI that I think some of you must have seen earlier in the keynote speeches. This is the demo where DLM would be one of the modules that sit in here. And so this customer is entitled to DLM as an example. So here you get an overview of the clusters, the health of the clusters, the number of policies that you have on these clusters, number of jobs that are running. And here in the cluster information, you can see which cluster is located in which region and the details of this clusters. Details is what's the usage of that, how many policies and how many nodes are there, and the location. And you can either go to Ambari, or if you have any policies that you add, you can go from this view too. And here is where you can add credentials, IAM credentials or secret or access key. So you can directly write into the S3 bucket. And here is where you can add the pairing. So you have two clusters. You want to copy the data back and forth. Here is where you can say that here is my source. I designate this as a source and this as the destination. And here is the policies page, where for each of the policies, you have further details of the policy settings. What's the source? What's the destination? The frequency of the policy, whether it's a minute level, hour level, or a day level policy. And you have queues. You can give a name to the queue, and you can change the bandwidth of the queue. Those are then the advanced settings. And here, as an example, this is a Hive database that we want to copy from one source to the destination. And it tells you how many times it has run in the past, whether successfully or whether there are any failures. And here you can see the log to see if there are any issues for the policy that you just ran. And if we can quickly create a policy, let's say a demo, and this is how you create an HDFS policy. And you can say that I have source cluster, and I'm setting, let's say, so select some source that I want to, directory that I want to copy, and I want to copy that into, let's say, S3. I'm using the credentials that I've already selected, and here is where you select a bucket. So you have a bucket that's called some San Jose demo, and then you have a folder called demo. So you want to copy the files into this one. So if I remember that, it was San Jose demo. That was my folder name. And I can use any encryption, whether no encryption or S3 or KMS. These are the two types of encryptions that we support today. And validate really helps you to validate if the IAM policy that I used, the credentials that I used, have right access to the folder that I just created on my Amazon. And once it validates, you can go back in scheduling whether you want to create it now. For the demo's sake, I'm just taking a minute level policy. And here is where you can give the queue name and the bandwidth settings, which I dare not set at this time. Okay, so the policy was created successfully. And you can see that it is currently running. Yes, it is currently running. And you can see here that the demo, so the demo folder that we have on Amazon is empty, and now we started running the policy. And let's see if that successfully ran. Oh, so I think this is running on an EC2. Okay, so let me switch to.
Just refresh it here.
Okay.
While it's running, you can probably show the Hive
So,
application.
so while this is running, okay, so this is one more, one thing that I can show you, that if the resources are not available to run, this is the experience that the admin will have, that for that time being, let's say it's an hourly or daily replication, that got just skipped and went into this one. Let's quickly show you the one that I wanted to. So this is the one that we were looking earlier. So you can see that I'm creating a new name, policy name. This is the HDFS replication that we were trying to do earlier. And it shows both incremental and the bootstrap. And then creating the schedule, selecting the cluster, selecting the source name. And for the folder, we'll select the apps, go into the web logs, and look at the destination. This has to be the S3. And now going to the S3.
Good.
And that's the path that we are in. And we saw that the folder was empty. Now we are going and giving that exact path name, and this is important to make sure that the right access is given to the folder that we created. And now I've used encryption type, SSE S3, validated it. Now I want to schedule as from now as a 1 minute schedule. And again, I'm not using any advanced settings for the name, or these are optional. Once the policy is created, we should be able to see that this S3 bucket was empty, and if you click, yes, it's in progress. It should take less than a few seconds to show us. Those are temporary files. Once, there you go. So you have all of the files. The first time it would be a bootstrap, and the second time it would be incremental replication of the files onto S3. Similarly, we have Yeah, so doing the incremental now. I want to show you the Hive demo, which is really cool. This is how you can really see the value of DLM for the customers. So looking at the policies, create an Hive policy. And it's important for you to know that the asset tables and storage handler-based tables are not supported at this point. We are working on that for the later revisions of DLM. And now I'm selecting the source. The database that I selected is Bangalore 1. And yes, it's on the on-prem cluster that we are selecting. And the destination is another on-prem. And validating the database, whether that database exists on the destination site. And scheduling for 1 minute, and skipping the advanced settings. The policy is successfully created. And if you see that the job is successfully running. Now I want to use these Zeppelin notebooks to see that on the other side, on the target side, the data, the Hive table data, the first time it copies entire data as the bootstrap. But the second time on, we will see that we drop a partition on the source, and then it drops the partition on the other side. So those are the 3 partitions that we have. And now we are adding a new partition here, Queens. We are adding that and making sure that it shows up on the source. Now we can see 4 boroughs, New York boroughs. And the other side, just want to make sure that the policy is running on the DLM. Yes, so the second time it successfully ran. Now if I want to go back in to see on this target Hive, we should see that on this, the Queens was added on the source. Now if it is an incremental replication, it should show up Queens on the target side. So that means it's incrementally replicated the data that was added, which was the Queens one. So that's the quick demo that I wanted to show. And going over, so that's the demo scenarios that we went over. And definitely want to also look at the use cases that we supported for our customers today, whether it's a pharmaceutical industry or whether it's finance or employee-based industries. We support the solutions for replicating the data, metadata, and security policies. So that's the common thread that you see across, in addition to the GDPR compliance. And so this is the tiering that we have, which we are also building to reduce the total cost of ownership for the customers. Here you can see different tiers. We give the ability to DLM users to create the tiers, and whether it's HDFS tier or HDFS data or Hive data, you can schedule those tiering policies. And if it is an inter, you can base it on whether it's an HDFS directory that you're looking at or whether it's a pattern matching databases for Hive. You can create all of these policies and make sure that you only allocate the server space that's really required for the customer. So this is something that's coming up as part of DLM features. So now want to ask Sweta if she can go over the technical overview of how this DLM was really developed and what the value add that we added on top of the community project.
Because of shortage of time, I'm just going to cover it quickly. If you have any questions, I can answer it offline. This is basically the data fabric that Tarun talked about in the keynote as well. You have various use cases where you have multiple clusters. You have multiple clusters on the on-prem. You have clusters on cloud. You will have to move the data around because of backup scenarios, or you want to move the data because you want to run ad hoc queries on the cloud to try out new services, or because of the capacity constraints and things like that. This is where DLM comes into picture, which is part of the data fabric. which lets you do replication, the disaster recovery, tiering, and the backup and restore. Typically, when anybody talks about replication, right, there are two modes that they talk about. One is active replication, and the other one is active standby replication, right? Active replication is where both the masters are active and the applications write to both of them concurrently, and readers can read from any of them, right? That gets into a very difficult state to manage as such, because there can be conflicts because both the writers are writing to the both the masters. It's also difficult for the applications who are reading to manage this data because they don't get a consistent view. It depends on what time they read the data. They might get different set of data depending on the conflict resolution, right? So as opposed to that, there is active standby replication where there is only one master which is active, where the write applications write the data, and then the data is replicated asynchronously onto the slave, and the applications can read from the slave directly, right? This gives a consistent view of the data, and it's very easy to manage the data in that case. So what we use everywhere in our DLM is active standby replication. Note that this active standby replication is at the data set level. So because you replicate the data from, say, production cluster to a DR cluster, not that the DR cluster itself is read-only. So this is just at a data set level. If you replicate from the source to the target, this data set is an active standby thing. And from the DR cluster, you can always set up a replication from the DR cluster into a production cluster for all the summaries that are generated and things like that. So the DR cluster is still usable for either the read-only workloads, or you can generate the data which is outside of the data that's replicated as such. This is a multi-cluster setup where you will have one DataPlane instance that's deployed. And you can have clusters that are deployed either as IaaS clusters on the cloud or on-prem clusters. And you can set up replication between any of these combinations, between any of the clusters on the cloud or on-prem. This is the DPS ecosystem that we talked about, where there's a DPS which gives a single pane of glass to access multiple clusters and multiple data sets across data lakes. I'll take some time to explain this. We have, there is a concept of a DLM UI that is hosted in the DataPlane service. They are deployed as Docker containers in the DataPlane. And there are agents that are required in each of the clusters where a replication is required. These are called DLM engine in this case. And these are the different services that DLM engine interacts with. A replication policy, when it is scheduled, as Neeru showed, right? So this replication policy is scheduled on the target cluster always, and on the target cluster, depending on what the replication schedule is, it sets up replication at that specific schedule using the scheduler, and it launches the jobs on the target cluster, and which pulls the data from the source cluster and writes the data to the target cluster, right? So all the inter-cluster communication happens via secure channel. We make sure that all the communications are via SSL so that both the data and the APIs that go over across the clusters are secure. We also make sure that all the calls go via NOGs so that the setups that are required for a secure setup, it simplifies because of the single NOGs gateway. So both the HDFS replication and the Hive replication uses the same model of a pull-based replication. And as part of the replicating the data and the metadata associated with it, we also replicate the ranger policies associated with the data as well. This is a quick thing on the HDFS replication. Under the hood, it uses the DCP. That's what it is used currently, but tomorrow we can change it to something else in the background, which is more optimized, because DCP launches map jobs for everything which is not optimized. It can support both a non-snapshot-based or a snapshot-based replication. DLM manages the snapshots in this case using the HDFS snapshots. DLM takes care of doing a diff between two snapshots to figure out what has changed and replicates only the data that has changed. We also have a recovery that we do on the target. If replication fails in between, we recover the state of the target to previous known good state, so that target is always in a consistent state for your consumption. Automatically, the encrypted data is handled. So we do support the cases where source is encrypted with one key and the target is encrypted with another key altogether. We do support replication to the cloud as well, where we use a push-based replication, where we push the data into the cloud storage directly. We use cloud connectors, which use a secure channel on HTTPS. We don't require a cluster on the cloud to push the data, so it's directly pushed to S3, for example. We do support the cloud-native encryptions as well, which are the SSE, S3, and KMS. And the on-prem can be encrypted with the KMS on-prem, but on the cloud, it can be encrypted with the cloud-native encryptions, which are the server-side encryptions. There is a lot of work that went in Hive to make sure that the data is consistent when the data is replicated. Hive data is nothing but the data and the metadata, right? So, I mean, most of the replication uses for Hive includes just replicate the HDFS files and then replicate the metadata. That doesn't work consistently, right? Because this is a DB. The data and the metadata that's replicated can go out of sync. It's possible that you replicate the data, but when you replicate the metadata, it has a new partition, but the data is not replicated. So it's very important that this data and the metadata go synchronously. So there are a lot of changes that are gone into Hive component itself, Hive service itself, to make sure that this data that's replicated is consistent. And it's a very optimized incremental replications. Hive actually tracks each of the events that happen on Hive, like your add partitions or any metadata operations or any data change operations that happen. And when the replication happens, only the delta gets replicated. And this happens serially in the order in which these events are triggered on the source itself. So the data is always consistent on the target because data is the most important part and it makes sure that the data is consistent. By default, we do handle the encryption on the Hive databases, and the Ranger policies are replicated as well. So this is some of the details of the Hive replication, Hive and the HDFS replication that's supported currently. I'll quickly give an overview, but I guess we are running out of time, so I won't go into the details. We do support Hive on-prem to cloud replication as well, where we do move the data into the cloud storage directly, but the metadata gets replicated into something called a shared services, where you can launch more ephemeral clusters which point to this shared services where the metadata exists and your data is on the cloud storage. That's something that is supported as well. There is another talk on the Hive replication details as such. It's there tomorrow at 9:30 a.m. If you need more details about the Hive replication, feel free to attend. And that's all I had.
Thank you.